Welcome back, friends. Today we are going to start our discussion about the first Form 5 topic in chemistry, which is general chemistry. So this is the 2021 update of the session, and I hope every one of you will enjoy the session and you'll be able to understand many things in general chemistry. So I would like to go together with you, and in this section we'll be able to view the notes, and then we'll go together in everything which we'll be doing in this session. So first, let me give you a brief introduction of the advanced chemistry. Advanced chemistry, we study it in major 4 branches. However, there are other small topics. The major 4 branches of advanced chemistry, we have general chemistry, and then from there we have physical chemistry, we have organic and inorganic chemistry. We have other branches of chemistry or small topics such as electrochemistry and other topics such as environmental chemistry and soil chemistry. Like in major, in general chemistry, and the general chemistry is the foundation for you to understand the other topics in chemistry. If you understand general chemistry, it will be easier for you to understand organic chemistry, inorganic chemistry, and even physical chemistry. General chemistry discusses about the principles which we are using in other topics, discusses about the basic concepts which will be applicable in other topics. Because as we know in chemistry, we are discussing about the properties of matter, and matter is made up of atoms, which are made up of elements, and elements they are made up of atoms. Now let's see the introduction. By introduction, we are saying that general chemistry is the branch of chemistry which deals with the nature of matter. It's the branch of chemistry which deals with the nature of matter. So, nature of matter, how matter is made up, and then it also deals with the structure of an atom, the discovery of subatomic particles, which are electrons, protons, and neutrons, fundamental concept of chemistry, such as quantum theory, and the wave-particle duality of matter and the radiation. Also, it deals with the discussion about chemical bonding or chemical combinations and the theories explaining chemical bonding, shapes of molecules, and their relation to physical properties of matter. So in general chemistry tutaenda kujua kwamba why baadhi ya materials unazikuta they are hard, while other materials they are soft. The reason behind is because of the nature of bond which is making up the materials. Difference in the nature of bond which is making up the materials will lead to difference in the strength of these materials under different conditions. So if you apply force to some of materials they will respond by breaking down, but some of them they will not break. Why? It is because of the nature of bond which they are made up. So in general chemistry, it will be better if you understand the nature of many materials as you can, because this will enable you to answer many questions in exams, but also will enable you to ease your study in other branches of chemistry such as physical chemistry and organic chemistry, and even inorganic chemistry, depends on the knowledge of general chemistry. Now we are starting by discussing a little about the nature of matter, but the nature of matter will not be our concern. Our major concern in general chemistry will be atomic structure and bonding. But before moving to atomic structure, let's discuss a little about the nature of matter. So in the nature of matter, we are saying that all things are made up of matter, whose basic unit is the atom. So when we are talking about the nature of matter, we are discussing that all substances in the world, they are made up of the matter. All things which we know, they are matters. But matter itself is made up of atoms. So tunapokuwa tunaenda kusoma general chemistry, tunadiscuss kuhusu atom. Atom ni mdudu gani? Tunaposema matter, Najua wengi wenu mnaweza mkawa mnajua tu matter is anything which have mass and volume, any substance. So if we are talking of a paper, we are talking of a table, a board, we are talking of anything, even air, even gas, it is the matter because it has mass and volume. So any substance is the matter, any substance which you know, anything which you know is the matter. And the matter is made up of the atoms. Now what are the atoms? By definition, atoms or an atom is the smallest indivisible particle of an element which can take part in chemical reaction. It's the smallest indivisible part of an element. So atom itself is defined with respect to an element. Smallest indivisible particle of an element. But what is an element then? An element is the substance which cannot, by any known chemical process, be split up into two or more simpler substances. So we can say that matter, they are made up of elements. Different matter are made up of elements. And as we know from our Form 2 chemistry, elements ziko nyingi. I know huwezi ukawa umefika Form 5 chemistry, you don't know about elements. So matter, they are made up of elements. But from element, then we have atoms. Remember, an atom is the smallest particle of an element. So that means we have levels. And not only element, we have different levels. So from matters, here we will have several subdivisions. You will go down, then you will meet with molecules. And these molecules, we have macro and micro. We have macro molecules, and you have micro molecules. So let's take an example. We are talking from a matter like, let's say we are talking just simply the maize powder. Tunazungumzia matter kama unga wa mahindi. Unga wa mahindi is also matter. However, we know different matters. We know about trees. But I will talk example of the organic one so that to be understood, because even in biochemistry we study a little about this organization of the molecules. So to start with our matter, which is maize powder, let's say this is our matter. It has mass and volume. And from this matter, which is maize powder, we will have molecules, which some of them they are micro and some of them they are macro. Now, if you don't know, maize powder is the starch. So being a starch is made up of carbohydrates in nature. So what do we say about the macro and the micro molecules in the maize powder? In the maize powder, the macro molecules, we call them the polysaccharides. And the maize powder itself, it contains more of the polysaccharide, especially it is starch. So the macro molecules in the maize powder, we have starch. But we may have also the micromolecules. But most often ni kwamba ili tupate micromolecules from the maize powder, lazima we subject the maize powder into different reaction. For example, tunapokuwa tunapika unga wa mahindi kuja kupata ugali. That means ule unga wa mahindi ni starch. So ugali ni chakula ambacho ni starch. From there, tunapokuwa tunakula ugali au tunakula uji, that means what we are doing is ingesting starch. And as we know from the process of digestion, which we have learned in Form 2 biology, from this starch, ikifika kwenye mouth inakutana na salivary amylase. And by meeting the salivary amylase, it is broken down into the simpler molecules. Starch in the mouth, it is broken down to a molecule called maltose by the salivary amylase. And then from there, when this maltose moves down to the small intestine, it meets with the enzymes in the small intestine. So when meeting with the enzymes in the small intestine, the maltose is digested again to glucose. So now glucose is the simpler molecule, is the micro, because you have macro, which are larger one with the large molecular masses, but you have the simpler molecules which have small molecular masses. Now glucose is the simpler molecule which we can write it, because the structure of glucose is known that it is C6, then H12 or 6. It is the simpler molecule. And then from glucose, we can say about an element. We have carbon, then you have hydrogen and oxygen. These are the elements which are present in the glucose. But also from glucose, we can say about atoms. We have carbon atom, hydrogen atoms, and oxygen atoms. So in case of element, we have carbon, hydrogen, and oxygen elements. But here we have 6 carbon atoms. You see? So from molecules, we are moving to elements. We are moving to elements. And these elements, they are made up of the small, indivisible particles. I mean, elements, they are indivisible, small indivisible. But these elements, they are made up of the smallest particles which can take part in chemical reaction, called the atoms. So all matters. Here we have given an example of maize powder is our example of matter. But all matters, they are made up of the atoms. So for any matter, we can move in this sequence from a matter to an atom, is how we have explained in this maize powder as one among the example of matter. So now we are saying that an understanding of atom paves the way for understanding substances, their nature, manipulations, and how they can be used. An understanding of atoms paves the way of understanding substances, their nature, yani why they appear in those physical states na vitu kama hivyo, na pia kuweza kuelewa kuhusu manipulations and how they can be used. Manipulation, that means kivipi tunaweza tukafanya labda atom ifanye a certain reaction. It is because of the understanding of the nature of that atom. Now from there, we can move to start our discussion about the atomic structure. We have already introduced about the nature of matter, that all matters, they are made up of atoms. All matters are made up of atoms. Now let's discuss about the atomic structure in the first part of our topic of general chemistry, and in the second part of our topic of general chemistry, we'll be discussing about bonding. Bonding is discussing how these atoms, now they are bonded to each other so that to give structure which is stable and which can perform a certain function, or which can be used in a certain way. So in the first part of subtopic of general chemistry, we are studying about atoms, and then in the second part we are looking at how these atoms, they bond to one another, they join to one another to form stronger molecules or to form weak molecules, and how these weak or stronger molecules, they can be used in different aspects of life. So now we are saying that in this chapter of atomic structure, in this chapter, we will learn about atomic theories and their amendments. When you are talking of the amendments, is just like drawbacks, yani vitu ambavyo atomic theory vilishindwa kuelezewa kwa hiyo atomic theory. So we will learn about atomic theories and their amendments, and then we will learn about subatomic structures or subatomic particles. Subatomic particles. That means in an atom there are other smaller. And then we'll learn about the hydrogen spectrum, we'll learn about the quantum theory and the electronic configuration. So the topic is a bit long, but don't worry, it's one among the easiest topic in chemistry. However, for some students huwa inawasumbua, lakini it's one among the easiest topic. So we'll start with what we call the Dalton atomic theory. Dalton atomic theory. Dalton atomic theory. So who was Dalton and what is the Dalton atomic theory? John Dalton in 1808 mwaka 1808, John Dalton established the idea that matter is not continuous but particulate, which is matter is composed of tiny particles called atoms. So John Dalton was the first scientist katika mwaka 1808 aliestablish idea kwamba matter is not continuous. For how we know is that, for example, this duster is simply continuous, mbona inaonekana imeunganika. But John Dalton here alisema kwamba it's made up of the smaller substances or particles called atoms. Now, there are some of the evidence for this. Kwamba how comes matter is not continuous? Alijuaje matter is not continuous? Because according to what we know, ingekuwa if we have water in the cup, tungejua kwamba simply what we have in the cup is simply water, and tungejua tu kwamba water is continuous because kama tukimwaga maji yanamwagika yote. Or if we have this plastic cup made of the polyvinyl chloride PVC, tungejua kwamba hii plastic cup is just continuous, kwani ina polyvinyl chloride ndani molecules. Sasa John Dalton alikuwa ndo mtu wa kwanza kusuggest, and we have some of the few evidence for the particulate nature of matter ambayo Dalton alikuwa amesuggest. We have few of the evidence. Our first evidence is the diffusion of colored crystals in solution. What was observed is that ukichukua colored crystal of any substance, more especially unaweza kuchukua colored crystal hata za salt, let's say it is copper 2 sulfate, which is blue in color. Then after that, take your glass or even your beaker. After taking your beaker, you may choose to put the crystals first and then add water. Or you may add water first and then put the crystals. So at first, utaona kwamba hizi crystals ziko hapa. Lakini as the time goes unakuta ile color of the crystal tend to spread. The color of crystal tends to spread. And later ile maji yote yanakuwa na color of the crystals. Sasa the question come, crystal tuliziweka hapa chini. Na hizi crystal hazijamove. Hatujaona ile crystal moja ikijump. Sasa kama hatujaona crystal ikijump, what made the color to spread all over the solution? It is because the crystals are made up of the smaller particles which are able to move. Crystals themselves as wool, they are not able to move. But as these particles dissolves, these crystals dissolves, the particles in this crystal, they tend to move in random motion. So since the particles in this crystal, they move in random motion, now how do we call these particles? We call them the atoms. So hapa tuna particle, tuna crystal, ambazo kwenye crystal kuna particles. So zile particles ambazo ziko kwenye crystal zikimove, zina spread all over the solution na zinatengeneza solution yote ya color. That's the first evidence. The second evidence is like somehow similar to the first one, but they are two different evidence. This is the dilution of potassium permanganate solution. Dilution of potassium permanganate solution. As we know, the color of potassium permanganate is purple. So what did we expect about dilution of potassium permanganate? Tulitegemea tukiongeza maji kwenye solution ya potassium permanganate, yale maji yawe kivyake, kuwe kuna weupe. Yani, if this is the potassium permanganate solution, tulitegemea addition of water in this solution. Mara kama tukiadd water, tulitegemea water itengeneze region yake within the solution. But what is observed is that the solution tend to mix. Yani, you are adding water but the solution remain purple. You are adding water, the solution remain purple. Labda if the dilution will be larger, yani kama umeongeza sana maji, basi solution ita change color kutoka purple kwenda rangi nyingine. So now, how do we say about this phenomena of the dilution of potassium permanganate solution? How do we say about this? Tunachokisema ni kwamba it is because potassium permanganate is made up of the smaller particles which are called atoms, and the water itself is made up of the smaller particles which are called atoms. So the atoms of potassium permanganate, they are moving in random motion in such a way kwamba tunapokuwa tuna add water, they are moving into the atoms of water, so zinachanganyana zenyewe. Finally unakuta the whole solution is uniformly colored. That is the evidence from dilution of potassium permanganate solution. Now, a study about matter started in year 1880s when John Dalton postulated his Dalton's atomic theory. So he was the first person to suggest about the particulate nature of matter in 1808, but also he was the first person to start postulating about the structure of that atom. Your atom ipoje. So what we are going to discuss now is what we call the assumptions of the Dalton's atomic theory. Assumptions of the Dalton's atomic theory. So when we are talking of the assumptions is like ideas. Dalton aliwaza nini? Okay, whether alifanya experiment au hakufanya, but most often kuna properties aliziona ambazo zilimfanya suggest nini? Dalton's atomic theory. So hizi ni ideas of Dalton. Postulates, sometimes we are calling them the main ideas or assumptions. So the main ideas or the assumptions of the Dalton's atomic theory, we are calling them assumptions because if later they get evidence, that means they become true. But if they don't get evidence, they are not true. Just he postulated, he just he write down, he tell people his ideas. So main ideas are Dalton's atomic theory. The first idea is that matter is made up of small indivisible particles called the atoms. Matter is made up of small indivisible particles called the atoms. And the atoms, hiyo ni ya kwanza, matter imekuwa made up of the small indivisible. Now one thing we need to note here is that Dalton is saying an atom is indivisible. We can't divide an atom into smaller particles. That is the major thing we need to understand in the first postulate. But in the second postulate, atoms can neither be created nor destroyed during any physical or chemical change. Alisema atoms can neither be created nor destroyed in any physical or chemical process. So according to Dalton, alisema atom hatuwezi kumcreate au tukamdestroy, hatuwezi kumtengeneza au tukamharibu. Atom is there. Yani kama vile atom ilishaumbwaga ndio inaishi vile. Nobody can create it, nobody can, it's like human being. Human being you can only destruct but you cannot create. It's because toka alipokuwa created ndio yuko vile vile. That is the second idea. But the third idea is that atoms of the same elements resemble one another in properties such as mass and volume, but they differ from atoms of another element. Atom of one element resemble one another in properties. Resemble, they are similar, or they are alike. Resemble, zinafanana kwenye properties mbalimbali. Tumetolea mfano hapa ni mass and volume. But according to Dalton ni kwamba atoms of one element, they resemble one another in every property. Chemical reactions, mass, volume, atomic number, everything. Number of electrons, number of protons, everything. Atoms of one element, they resemble according to Dalton. But the fourth idea is that atoms of different elements are different in all aspects and have different physical and chemical properties. That the atoms of different elements, let's say you have two different elements, the atoms, they will have different properties, from atomic numbers, atomic mass, volumes of the atoms, then reactions, physical properties of these atoms. According to Dalton, he said they are different. But the last idea, or the last assumption of the Dalton's atomic theory, was that the atoms combine with each other in simpler whole number ratios to form compound. Atoms combine with each other in simpler whole number ratios to form compounds. So, according to Dalton, his atomic model, he suggests that an atom is the solid sphere which is indivisible. So according to Dalton, tungesema the structure of an atom, according to Dalton, was simply looking like this way. It is the complete sphere which is indivisible. And inside this sphere, there is no any smaller particles. There is no any smaller particles. Because this sphere, it is indivisible. Ni indivisible. Kwa watu tukasema kwa kuna smaller particles pale. Kwa sababu that's what Dalton, he postulated about the structure of an atom. He postulated about the structure of an atom. Now from there, we can move forward. The idea that Dalton suggested about the structure of an atom, they were not correct. And due to several experiments, later they discovered that atom has some of the particles inside it. So that means an atom is divisible. Sio tena indivisible. Indivisible manake you can't divide it into smaller particles. But according to how they performed different experiments, they later become knowing that atom, it is divisible. So if an atom is divisible, so they came up with what you call the modern atomic theory. So modern atomic theory, sometimes we call them the limitations, or the weakness, or the amendments of the Dalton's atomic theory. The limitations, the weakness, or the amendments of the Dalton's atomic theory. Let's discuss about the amendments or the limitations of Dalton's atomic theory. So, about limitations of Dalton's atomic theory, we are saying that Dalton's atomic theory was widely accepted initially. Mwanzoni ambapo kulikuwa hakuna idea nyingine, Dalton's atomic theory was widely accepted. Up to the end of 19th century, therefore, a series of experimental evidence showed that the Dalton atomic theory has some limitations. A series of experimental evidence ambazo zilikuwa zimetokea. So despite its limitation, the Dalton atomic theory gave a major foundation on the study about the nature of atom. The following amendments were made on the Dalton atomic theory that led to the modern atomic theory, which states as follows. So these limitations, they are sometimes called the ideas or the postulates of the modern atomic theory. Now, according to the idea of Dalton, kama alivyozipanga ideas za Dalton, from the first to the last, every idea of Dalton or every assumption of Dalton's atomic theory has its own amendment. Kwa hiyo, for every assumption of Dalton's atomic theory, we have its limitation because of different experimental evidence ambazo zilikuwa zimetokea. So, first idea of Dalton's atomic theory, tulikuwa nasema kwamba an atom kama atom, it is indivisible. Yeye alisema kwamba atom it is indivisible. Matter they are made up of the smallest indivisible particles called atoms. Matter are made up of smallest indivisible particles called atoms. Indivisible. I told you kwamba indivisible ndio neno ambalo la kushika sana. Kwa nini? It is because pale ndipo ambapo Dalton alikosea kusema indivisible. So ninachokisema, what is the modern atomic theory saying about this postulate? Ni kwamba the atom is no longer regarded as indivisible or the smallest particle, because the smallest particles which are smaller than the atom are known. So different experiment revealed the smallest particles which are smaller than an atom, which are electrons, protons, and neutrons. So due to the presence of these particles, an atom is not the smallest again. So we can't say matter, they are made up of the smallest indivisible particles called atoms, because the atoms, they are divisible into electrons, protons, neutrons, and other subatomic particles. Yani ziko nyingi. In our level tunasoma hizo tatu: electrons, neutrons pamoja na protons. So that is the limitation of the first idea. In the second idea, Dalton alisemaje? In the second idea, Dalton alisema kwamba an atom cannot be created nor destroyed. Cannot be created nor destroyed in any physical or chemical process. That idea is wrong, because nowadays we have radioactive reactions which can create an atom by combining them. We call it the nuclear fusion. But also we have radioactive reactions which can destruct one nucleus of an atom to smaller nucleus with smaller masses. We call it the nuclear fission. We have fusion, which is joining, and fission, which is splitting. So the existence of radioactivity reactions such as nuclear fusion and nuclear fission has revealed that it is possible to destroy an atom and it is possible to create an atom. We are creating an atom by joining two or more nucleus, but you can destroy an atom by cutting through and making more than one nucleus from one atom. So we are saying that atoms are no longer regarded as indestructible. They are no longer regarded as indestructible, as radioactive atoms may be destroyed by spontaneous decay or created by atomic fission. May be destroyed by spontaneous decay or created by atomic fission. Radioactivity can either create or destroy atom nuclei. Can either create or destroy atom nuclei. That is the amendment of the second idea. The third idea of the Dalton's atomic theory, Dalton alisema nini? Alisema kwamba atoms of the same element, they are alike or they are similar in all properties, and they are different from atoms of another element. So according to Dalton, alichokisema ni kwamba haiwezekani tukawa tuna atoms of the same element ambazo zikawa zina mass tofauti. Haiwezekani tukawa tuna atoms of the same element ambazo zikawa zina number of neutrons or number of electrons tofauti. So normally or for most circumstances, this assumption is true. But we have existence of what we call as isotopes. And what are the isotopes? Isotopes are simply they are atoms of different elements having isotopes. They are atoms of the same element having the same atomic number but different mass number. For example, we have isotopes of carbon. We have carbon 12, which is carbon 6, 12, and then we have carbon 14, which is carbon 6. These two, they are called as isotopes. That means huyu hapa ana atomic number 6 mass number 12, atomic number 6 mass number 14. But also we have atoms of different elements, even hydrogen. We have hydrogen 1, then we have hydrogen 1, 2, and then we have hydrogen 1, 3. All of these, they are atoms of hydrogen, but they have the same atomic number and different mass number. The difference in mass number is called by the difference in the number of neutrons. As we know, atomic number is equal to the number of electrons and is equal to the number of protons. So why the mass number they are different? It is because mass number A is equal to number of neutrons plus number of protons. But in number of protons is also a number of electrons and is equal to atomic number Z. So from there, similarity in atomic number means we have the same number of protons, the same number of electrons, and the difference in mass number means we have different number of protons. So from here to here to here, the number of electrons, they are the same, but the number of neutrons, they are different. Existence of isotopes inakataa idea ya tatu ya Daltons atomic theory ambayo inasema atoms of the same element lazima ziwe alike na lazima zitofautiane na atoms of the different element. But since atoms of the same element, they may have different masses, that break or that goes against with the idea of Dalton. So we are saying that not all atoms of the same element are alike due to the existence of isotopes, which are atoms of the same element with the same atomic number but different in mass number due to difference in number of the neutrons. Example, we have carbon 12 and carbon 14, which are different atoms of the same element having different atomic masses. But from there, the fourth idea of Dalton, what he said in the fourth idea, Dalton alikuwa anazungumza kuhusu atoms of different elements, na akasema kwamba atoms of different elements zenyewe, they must be different in every property. We can't have atoms of different elements which are alike or which are similar in any of the property. But that idea is not correct. Why it is not correct? It is because of the existence of the isomers and even isotons. So what are the isomers? We are saying that about the fourth idea of Dalton, in most cases it is true. In most cases. But we have few exceptions in isomers. In some very few cases, atoms of different elements may have the same atomic mass. Thus, the idea that all atoms of different elements are different is not correct. A good example of this is both argon and calcium have the same atomic mass of 40. Argon and calcium, they have the same atomic mass of 40. So, if we have argon and then you have calcium, argon, if we are counting the atoms in the periodic table, this will be number 18. Then it has atomic number 40. And this is atomic number 20. The mass is 40. So these are the atoms of different elements, but they have the same mass. Dalton alisema atoms of different elements, they are different in every property, But here we have seen atoms of different, they have the same mass. So if atoms of different elements, they may have the same mass, that means we get an idea that Dalton's atomic theory, the fourth idea is not correct. So another example, we may have carbon isotope, carbon 14 and nitrogen. Carbon 14, it is carbon 6, then 14, and nitrogen, it is 7, and then 14. So you see, they are atoms of different elements, but they have the same atomic mass. We call this the isomers. But also, we have existence of what we call the isotons, which we will discuss in detail later. We have existence of what we call as isotons. Isotons. These are the atoms of different elements, having different atomic number and different mass number, but the same number of neutrons. They have the same number of neutrons. So we'll discuss them later in detail when we discuss about the fundamental particles of an atom. So we may conclude that presence of isomers make the assumption that atoms of different elements are different in all aspects inevitably in a small extent. From there, we can move to the last assumption of Dalton's atomic theory, which is said that atoms may combine in small, simpler whole number ratios to form compound. That's what Dalton is suggesting. Atoms may combine in small, simple whole number ratios to form compounds. This idea is not correct because atoms, they may combine in even complex ratios. So the ratio in which different atoms combine may be fixed, but may not always be simple. May be fixed, but may not always be simple. Yani simple ni kama vile 2, 3. Manake ni small, walisema ni small, simple fixed ratios. So simple, they're just small numbers like 2, 3, 4. But sometimes the ratios in which the atoms they combine, they are large. Fixed but not simple. Example, carbon forms the very complex compound of organic. And an element, silicon, occurs in some very complex silicate and thus reduces the degree of correctness of this assumption. Our best example of carbon which we may give is maltose, which is C22, C12, H22, and oxygen 11. It's just an example of the ratio. So here tutapata 12 ratio 22 ratio 11. You see, the ratio is fixed in all molecules of maltose, but this ratio is not simple. The ratio is not simple. It is complex ratio. Now this marks the end of our first session in atomic structure, which we have discussed about the Dalton atomic theory, the nature of matter and the Dalton atomic theory. In the second session, we will start our discussion about the fundamental particles of an atom. Fundamental particles of an atom. We shall see what an atom is made up with. An atom is made up with what particles? The smaller particles from an atom. So from here, later I wish you nice studies, and don't miss the second session. Don't miss the next session. Thank you.